Now we can see how we can perform the PCB routing. So we can go for either manual routing operation or automatic routing. Before performing the routing in the PCB, try to change the size of each of the pins. Basically for ICs we need to change the pin size. So for that what we can do is just right click on each of the pin like this, then choose the option edit pin. In the style option you can select the size. So here you can have square shaped pin as well as circle. So this S represents square shape and the C represents circle. Okay. Normally the first pin of an IC is represented using square shape. So we can choose the square. Choose at least size 70-30. So I am choosing it as 70-30 for better PCB. So you can see the change in the size of pin. And again for the next pins we can perform the same operations. Okay. So here I am choosing circle shape pins. So you can select C 70-30, and for next one again 70-30. Similarly, change all the pins of an IC, and if there is any other pins with very small in size, that also can be changed like this. Okay. So the size, you can see I have changed all the pins. Now within the pin you can see two different circles. One with the pink in color and second one is brown in color. So in the size option, in the style option, you can see the two numbers. For example, C 70-30. 70 represents the size of the outer circle and 30 represents the size of the inner circle. Okay. Based on that, you can choose the size. Then after completing the edit pin options, you can go for automatic routing. So again for that, select the tools. There you can see auto router option. Click over there and a new window will be opened. Here you can just go for begin routing. Okay. No need to change the settings right now. Later we can change. Okay. So the automatic routing option has been done. And in the PCB you can see two different colored connections. The red represents the top layer connection and blue represents the bottom layer connection. Since we are going for single layer PCB, we can only use this blue colored tracks. So what we have to do is we need to remove or we need to reroute all the red colored routes. So here if you observe, you can see these colors are not properly visible. So if you want to change the color of the background, you can change it in the view option. Here in the view, there is an option edit layer color. Select that. By default, it is in black paper. So you can see the background is in black. You can change it to any other color. So I am changing it to white for a better view. Okay. So these things are better visible now. Now we can delete all the red colored routes. Okay. So that is the first thing. You can delete all the red color. So I am deleting that. All the red color routes I am deleting. Then we have to perform manual routing for these red colored routes. Okay, that is the next thing we have to do. So let me start with the first connection, that is for the J1. So for doing the manual routing, you have to select the select the track mode option at the left side panel. Select it. Then again the width of the track you can choose it here. So again by default it is very thin. So I need to change it to some T70 or T60. You can choose according to your wish. So I am keeping it as T60. Then from there we have to connect pin number 1 to 7. So the Proteus is showing the exact connection by this green colored line. So what you can do is just click over that pin and it will show where that connection has to go. Okay. So I am making it like this. All these things can be done according to your idea. Okay, I think the size is not changed. Anyway, we can change it later. The next connection is for this pin number 2 and pin number 1 here. So that I think we can connect it through this point. Okay, from the capacitor we can connect it. Then for the next connection, we need to think. Okay, suppose if you want to change the width of the track, just click over the right click over the track. There is an option called change trace style. Select at least T60 for a better track. Okay, so I am clicking it as T60 now. So you can see the width of the track has been changed. So let me change all the tracks like that. So here you can see when I change the size of the track, there is an error that is shown by this red circle, and a pop-up message has also come. So that represents, or that means, there is an interconnection between the pin number 2 and 3 according to this track. So we need to adjust that track in order to remove that error. Okay, so I am changing that like this. Then here also I am changing. So every track you can change the label. So I have changed the width of all the tracks now. Next, we need to complete the connection. So for doing that, you need to think, and you can do, or you can perform rearrangement of components so that there is no overlap between any tracks. So you can see there is a connection required between pin number 3 here and pin number 1 here. So if I go to connect that through a track, there will be definitely an overlap. So I need to do some sort of arrangement between these resistors so that I can remove the overlap. Okay. So in order to complete the routing, we need to rearrange the components according to the requirement. Okay. So that you have to do according to your imagination and your circuit. So what I have done is I have changed the position of these resistors. Then I am trying to reroute. Okay. So when you reroute, always keep in mind that there should not be any overlap between tracks. Okay. So first what I am doing is I am connecting pin number 1 of J2 to that pin number 2 over there like this. Okay. Then from here I need to connect it here. Okay. Then let me change the size of this trace to T60. Here also I am changing it to T60. Okay, then again we are having 2 more connections here. 1, 3 to this 2, and then to 1, and from 4 to 1. So that we have to think how we can solve it. Now suppose if we want to connect 4 and 1, we can do that. There is no problem here as of now. So let me do it directly. So let me connect it here. Here also we can do that, 2 to this 1. Now if you observe from 3 to 2, if you connect it, you can see there is an overlap. So we need to find some path or some way of connecting from 3 to 2. Okay. So you need to think and find that, how we can connect it between 3 and 2 without any overlap. Okay. Just think it. I will also think, and we will see how we can do that. Okay. So we can try one method. What I am doing is, let me flip the resistor R2, then see what we can do it. Okay, so before that, let me delete that connections. Here there is a connection, here also there is a connection. Now we can flip or we can rotate. So what you can do is just right click over there, then perform rotate. Okay, on 80 degree rotated. Now see whether we can do that. Okay, so let me again draw that path from 1 to this connection here, then 2 to 1, also it is solved. Now there is again problem. Okay, so if you connect from 3 to 2, there is an overlap here. Okay, so the blocking track is this one. This is the problem. So we need to solve, or we need to change the path, this path through some other. Okay, so again we can think how we can do that. So what I got is we can change this path, this one. Okay, this path we can take it through some other way, and we can connect it between 3 and 2. So what I am going to do is I will take this path through this resistor or under this resistor. Okay, so for that let me again rearrange the resistor for a better tracking. So let me change this also, let me move a bit to the right. Then let me delete this track also. Then first let me connect 3 and 2. Okay, then we can see whether we can connect 4 and this. Okay, we can do that. From here let me take it through this way, through here. Okay, through here or here, wherever you want you can connect. It's showing where we can do it. Okay, I think the problem is solved. There is again one small error here, that we can connect it like this. There is a requirement of connection between 1 and 2. So let me connect it like this. Okay, so I hope all the connections are over. There is no more green lines. So I think our connection is over. Now what left is to change the size or pad size. Okay, so change it to T60. Here also T60, T60, T60. Again here. Okay, so all the connections I have changed the trace style to T60. Now after completing the routing, you need to see whether is there any unwanted interconnection between any of the tracks or terminals. That you can do it yourself, no problem. Otherwise, if there is any physical connection, the Proteus will show it with a red circle and an error. Then apart from that, what you can do is, if you closely observe these tracks, you can see there is a 90-degree turn. Okay, normally in PCB we will keep it to some 45 degree. If you keep it to 90 degree, the track will normally get damaged easily. So what you can do is right click over there, and there is an option here in order to change that turning angle. Okay, just click that and you can see how that angle has been changed. Here also there is a 90 degree, so that also you can change it. And where else? Here you can see on 90 degree, so that also you can change it to some other angles. So these all these are small things that you can do. Here again there is one. Okay, here another. Okay, that I think that is not changing anyhow. Leave it, no problem. Okay. Now whenever there is a track that is going just below IC or any other component, make sure that it is not connected to any of the terminals. Okay, that is very important. Here you can see there is a track going under this IC. Okay, so we should make sure that that track is not touching to the unwanted pins, or there should not be any other connection that is not actually there in the circuit. Okay, so that you can do. Now if you want to provide any text to this PCB, just for understanding what the PCB is, you can go for this 2D graphics text mode option. Just click that and click over the PCB. There you can type whatever you want. Okay, just like your name you can provide. Let me write it as name. Okay, that part will be available. That part will be there when you perform the copper PCB etching. Okay, so since our circuit is a multi-vibrator, let me write it as multi-vibrator, just for understanding what the circuit is after making that. Okay, So you can see that term will be